Standards 7.SP.1-4 are all dealing with data. This first standard, 7.SP.1, is about populations and samples. So we're going to look at this first problem. It says the local park has a pool and a soccer field. Are the people on the soccer field the population or a sample of the park? Well, they're just a sample. They are a part of the entire population, which would be the entire park. So a sample is just a portion or a part of a group. Number 7, complete the sentences using the words below. Everyone in a group is called the population. It is everybody. If you take a survey of some of that group, it's called a sample. We're just finding part of the group is always called the sample. Number 9, the Blue Lake Town Council wants to know if residents are in favor of a tennis court being installed at the local park. Match each term to the example it best describes. Well, let's just first notice that this is the council for Blue Lake Town. And they're looking at Blue Lake Town residents. So Blue Lake Town residents are going to be the entire population. Now we're going to look at two different samples and see if one of them is a good one, representative, or not good, not representative. Local tennis players. Well, they're building a tennis court. Are tennis players going to favor a tennis court? Of course they are. So that's not a good population sample. That's not a good representative sample of the population. The next one is randomly chosen residents from the town census. It's random, so that is a good representative population. A good representative sample of the population. So we take a sample group, and if it's random, it's a good representation. If it's not random, for example, if it's something that is biased, then it's not a representative sample. Standard 7SP2. This is using samples to make predictions about a population. So we're going to look at problem 1. Rachel randomly surveys 7th graders in her school and finds that 7 of 25 play a school sport. If there are 175 7th graders in the school, about how many are expected to play a school sport? That's kind of like a prediction. We're going to write and solve a proportion. So 7 out of 25 play a sport. That's a fraction, 7 out of, or 7 of. So there's 7 play a sport, and 25 is just the whole population or the whole group. That would be the total. So this is a sample. Let's compare it to the whole population. So there are 175 7th graders total in the school. How many are expected to play a sport? Whoops. Let me move that back. That would be unknown, so we're going to represent that with x. So now we're just solving a proportion. 25 times x is 25x. 7 times 175, that's 1,225. To get x by itself, we're going to divide both sides by 25, and x is 49. So about 49 students are expected to play a school sport. Number 2, a company samples 50 boxes of crackers to check their weight. They find that 2 of the boxes have the incorrect weight. The company policy is to stop production if more than 50 of every 2,000 boxes are incorrect. Should they stop production? So let's see what's incorrect to start with. 2 out of 50. So in our sample, 2 out of 50 are incorrect. In the population, we know there's a total of 2,000 boxes, and if more than 50 are incorrect, then they would stop production. So let's figure out X, the number that would be expected to be incorrect out of the population, and then just compare and see if that's more than 50. So we're going to solve a proportion. 50 times X is 50X. 2 times 2,000 is 4,000. Divide both sides by 50 to get X by itself. And we get that X is 80. Is this number more than 50? Yes, it's more than 50. So, yes, they should stop production. $80 would be incorrect. Or we would predict that 80 would be incorrect. Standard 7.SP.1-4.mp4. This is about comparing data. It says for items 1 through 4, use the box plots shown. We also call these box and whisker plots. A random survey of 7th and 8th grade students was conducted to find how many hours they spent reading per week. So number 1, of the two sets of data, which has the greater median? Okay, so the median would be the middle line, and we see that 7th grade has a greater median. Number 2, compare the interquartile ranges of the data sets. So here's the interquartile range for 7th grade. It goes from the lower portion of the box to the upper portion, so it's this entire box. For 8th grade, the lower portion to the upper portion, the entire box. And you can look at the size of the boxes. 7th grade has a larger box. It's longer than 8th grade. So the interquartile range for 7th graders is greater than the interquartile range for 8th graders. Number 3, compare the variability of the 7th and 8th grade data sets. We already saw that in 7th grade it had a greater interquartile range, but look at 7th grade's range. From the smallest to the largest, it's a greater range than 8th grade from the smallest to the largest. So, 7th grade has greater variability. It varies more. Has greater variability because the range and interquartile range are greater. It's more spread out. Number 4, what conclusion can you draw about how much time 7th and 8th graders spend reading each week? Well, overall, we can just look at which one is further to the right to see if they spend more time. Notice that 7th grade over here is further to the right than 8th grade. And the right, going further to the right on here, is increasing the time spent reading per week. So on average, 7th graders just read more than 8th graders. Standard 7.SP.1-4 is about describing data. Number 6, the dot plot shows a random sample of the number of deer observed by 25 participants during a 2-day hike. Use the means to make an inference. So, mean is where we add all the numbers and divide by how many there are. So looking at day 1, to get the mean for day 1, we're going to add all the numbers. 1, which there's 4 of those, plus 2, there's 4 of those, plus 3, there's 4 of those, plus 4, there's 2 of those, plus 5, there's 2 of those, equals 42 when we add up how many deer were observed, the number of deer observed by different people. And then we've got to divide. So now we're going to take 42 and divide by 25 participants. There were 25 values counted here. And what we get is 1.68. So on average, on day 1, participants saw 1.68 deer. Now for day 2, we're going to add these all up again for the second day. So we're going to find the day 2 mean. We have 2 deer observed by 5 people, plus 3 deer observed by 6 people, plus 4 deer observed by 4 people, plus 1 deer observed by 5 people. So we add those up and that comes out to 49 deer observed. But we're going to divide that 49 by 25 to get the mean. So when we divide by 25, we get 1.96. So the average on day 2 was seeing 1.96, or almost 2 deer. So let's make an inference. If they saw more deer on day 2 on average, then we could just state that. On average, more deer were seen on day 2. Number 8, compare the medians of the data set shown. Who spends less time online? So median just means middle number. They've got to be in order from least to greatest or greatest to least, but it's just the middle number. So if I look over here at the 7th graders, my middle number I could find by just crossing out one on each end. So I cross out one on the smallest end and on the largest. Smallest and largest, 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 and I've got 2 numbers here in the middle. And since they're both 90, we could say 90 plus 90, which is 180, and then divide that by 2, so we get 90. But what we could have also noticed is they are both 90. So on average, 7th graders, just the middle of 7th graders, spend 90 minutes online. Looking at 8th graders, we'll do the same process. We're going to say we're going to cross off the smallest and the largest, the smallest and the largest, smallest and the largest, smallest and largest, smallest and largest, smallest and largest, and all of these are 120, but I'll go ahead and go through them. Smallest and largest, smallest and largest, smallest and largest. Once again, we have 2 numbers in the middle. They're both 120. So I could add 120 plus 120 and divide by 2, but I know that's going to be 120. So 8th graders typically spend 120 minutes online. So who spends less time online? That would be 7th graders. We're finished.